Proof 4 of 5, we're nearly there, folks. Let's talk about double injective. Okay, so the first thing that happens of real note is by induction on n, leaving m general. Now that shows up here in the cock as just as an intros and an induction. Now we would do the exact same thing if we had said, you know, a generalized dependent of m, right? That wouldn't affect the text we would write in the informal proof at all. Generalized dependent is just a weird low-level cock detail. Okay, after that, you can see that there are two cases. Case, oh, that's way too big. Case 1, case 2. Here's case 1, here's case 2. And as usual, we're giving a little bit more detail than you might have expected just to keep people on track. Okay, next up, you'll notice that this intros m eq corresponds to this. Suppose that 0 equals double m for some m. And while we're at it, we go so far as to remind people of where we're headed. We must show that m is 0. Okay, after that, we're going to do some case analysis. So it says, so since m is a nat, we have one of these two cases. So that since m is a nat is just a way of reminding people of what kind of variables you're dealing with. I wouldn't say that it's necessarily strictly required. One thing I'll note is I just skipped over a tactic in cock that's simple and eq. Just didn't happen. If anything, that's simple and eq. We can use this to do that. That's simple and eq, right? That actually happened right here, right? This was double 0. So that's where the simple and eq went. We didn't even remark on it. I think that's really acceptable here. Okay, so there we've got the destructs. How do the various cases correspond? Well, in the former case, let's say m equals 0, we have 0 equals m immediately. So that's this. That's this. Now notice here we're using language to make it clear that like in the former case. So I'm not actually doing outlines, right? No outlines. No outlines? No outlines. I'm not doing outlines here because the cases are so simple, right? One is correct, the one I highlighted in purple, and the other one, as we'll see in a moment, that I'll get going here in pink right after. The latter case is impossible. We'd have double s of m prime equals s of double m prime equals 0, which just isn't going to happen. So that corresponds to this discriminate eq. Okay, hopefully so far so good. Let's see how it goes in the next case. So again, we need to introduce some things, but here we do it at the same time as talking about our goal. So we say our goal and then we give the thing that we're introducing. The goal, what color would be good? Green looks good for a goal. Right, we must show that, right? So this year we're just restating goal. Okay, and as usual, let me get this in the appropriate important red, we state our IH. Absolute must, especially if you've said something special like I'm leaving M general, it's extra important for you to say what the IH is, just to make sure everybody knows exactly what you mean by leaving it general. So here, for example, we're saying like where's the general part? Right, this is the general part. So we say, oh, that's totally illegible. This is the general part. That's only modestly illegible. So we're saying for any m prime, and then the property that we're proving, if double n prime equals double n prime, then n prime equals n prime. Now these cases, because one of them is more involved, I list in outline form. So we can see that here. Let me draw the comparison. Right, by cases on m. So this is like a more conventional way of saying it than we see for the blue highlight above, but it's all just as well. Again, I'll just note as I've gone over it that I've more or less passed over that simple in eq. If we wanted to highlight where it was, simple in eq, that's actually already happened here. This was originally double s of n prime, but I've gone ahead and just sort of reduced it immediately to save everybody the trouble. Okay, how does the last little bit of this go? Well, you look like a nice purple. So for the m equals 0 case, we have this contradiction, and that corresponds to this discriminate eq. Now, in the next case, we have some more work to do. Oh, and apparently my rendering is out of whack. I updated this on the website, but the thing I've copied here, I did not update apparently appropriately. So now you get to see what it looks like when I mess up the formatting. It's still, I think, fairly legible. So here we must show that s of n prime equals s of n prime. So there's our goal again, right? we have, and then we state just this is the assumption that we have in that context. So this is not quite an intros in any sense, but it's just sort of like, hey, remember what we've got? And then I'm doing a bit of computation here that corresponds, I would say, to this simple unique. Right? Well, look, if we have s of s of double n prime equals double s of m prime, that's equal to s of s of double m prime. But what I'm hoping the reader is following along with is I say is it something like this? So well, we have what? S of s of double n prime. And that's supposed to equal to double s of m prime. But that's the same as s of s of double m prime itself, m prime. I'm a parenthesis short. So and then the next thing to note is like, well, look, what I ought to be able to do is just sort of cancel these s's, and then we'll be able to find what's next. And that's exactly what we have. So let me get you, nice little pink. Injection equals e prime, that's this. It must be the case that double n prime equals double m prime. Now, here, must be the case. It's like, that's a bit of boldness, right? Like, does your reader agree? And in this case, hopefully you do agree that to have s of double n prime equals s of double m prime, it really must be the case that the inside parts are equal. Okay, then I assert, okay, well, look, at that rate, we ought to be able to apply our IH, right? Double n prime equals double n prime, then n prime equals n prime. We can apply that here. Wow, stars from stars, incredible. Right, so that corresponds, you look good. All of that corresponds to that. So again, we see sort of some complicated reasoning in Coq narrows down to some fairly simple reasoning in English. Okay. You may note, wow, Prof. Grimmer's used a lot more colors than usual to talk about this. And this is like, there's a lot more going on. And that's true. There is a lot more going on. So hopefully what you're able to do going forward, at least for this day, is take a careful look at the Coq proof and make sure you're translating the bits that somebody wants to know. There's all kinds of bits that nobody particularly wants to know. So here, for example, the simple and eeks up top are not so interesting. But then also the last three tactics I've highlighted up here in blue, right? These guys. Well, nobody cares about the details of those. It's more that just look, once we know that double n prime equals double m prime, then we're made because the IH covers us to show that n prime equals m prime, and therefore s of n prime equals s of m prime. And that logic, to me, flows very naturally without having to think about anyone being concretely rewritten in anyone else, though, if we wanted to be careful and make it precise, we could using these Coq tactics. Anyway, I hope that's clear to you. One more video coming at you, one final proof coming up next, and that'll be it for today. Cheers, y'all.